All right, geometry students. So today we got lesson 6.3, and what we're going to be looking at is how we can prove that a quadrilateral is indeed a parallelogram. All right, now remember quadrilateral is a figure or shape that has four sides to it. So we're going to take a look at when that would actually make a parallelogram. All right, so in 6.2, we identified the properties of parallelograms, what actually makes those. Now what we're going to look at is some ways that we can identify if a quadrilateral does actually indeed fit into that category of parallelograms. All right, and here's the way we do it. We have some theorems that help us out, and what these theorems do is they explain like ways that a quadrilateral could be a parallelogram, and it gives us the least amount of info required, the least amount of information needed to be able to tell if we do have a parallelogram. Okay, so here's our first one that we need. If we have a pair of opposite sides that are congruent and parallel, we can tell that that would make a parallelogram. All right, this one here, if both of our opposite sides are congruent, then that makes a parallelogram. The next one down here, if our opposite angles are congruent to each other, then it would end up making a parallelogram. And a couple others that we have here, if you have one angle and its consecutive angles, so the angles next to each other, so these two angles and these two angles, all right, if both of those consecutive pairs are supplementary, then you would have a parallelogram. All right, so to kind of put this into perspective, let's give us a number for x. Let's say x was 50 degrees. All right, so then if that's angle A, angle B is 180 minus 50, so that would be 130, and angle D would be 180 minus 50, so that would also be 130. Okay, so if you look at this situation, angles A and B are supplementary because they make 180, and angles A and D are supplementary because they end up making 180 degrees. All right, so that's kind of what you're looking for, is one angle that is supplementary to both of its consecutive angles. And the last thing we can look at is when we have our diagonals bisect each other, then that quadrilateral would end up making a parallelogram. All right, so bisecting, remember we've used that word a lot last semester. That means that both of these diagonals are creating two congruent lines, segments, out of each diagonal. So these two would be congruent, and these two would be congruent. All right, and again, like some of these theorems we've worked with, some of them don't have names like these guys here, so we simply just abbreviate what it is that they're talking about. I wish they did have some names, but it would make it a lot easier, but sometimes they just don't. Okay, so let's apply that to the problems we are going to be working with today. Okay, so here we're given this quadrilateral, and we need to show that this quadrilateral is a parallelogram. Okay, so they're giving us some information here. Looks like some algebra to work out, and we need to show that that's a parallelogram. All right, so what we're going to do is we're going to find the length of each one of these sides, and then we're going to go back to our theorems and determine which of those conditions, which theorem proves that that is a parallelogram. All right, now what's kind of nice about these is they're giving us some numbers for these variables, so we just simply have to work out the math on those. So let's start with JK. All right, first we want to find what the length of JK is. So JK is 15 times A minus 11, and they're telling us A is 3. All right, so if we write that out, we have 15 times 3 minus 11. All right, and then that's going to get us 34 for JK. All right, and we're going to do the same thing with each one of these other line segments and see what we have. All right, next we'll do LM. All right, if we take a look at LM, we have 10 times A plus 4. So that's going to be 10 times 3 plus 4. All right, and that's also going to be 34. All right, we don't need to spend a lot of time on these. We can just work that math out. Next, we'll do KL. All right, KL is 5B time, or 5 times B plus 6. We have 9 for B, so 5 times 9 plus 6, and that's going to get us 51. All right, last one we got is JM. Okay, so if we do the math for JM, it's 8B minus 21, so 8 times 9 minus 21. All right, work out the math on that, and we end up with 51. Okay, so looking at the lengths of these sides, we can see that these two are congruent. They're the same size, and so are these two. All right, so JK is congruent to LM, and KL is congruent to JM. All right, so with that information, we have enough information here to apply one of the theorems we just learned about. I'm going to flip back and we'll take a look at it. We need, let's see, not those, this one right here. All right, which shows if you have opposite sides congruent, then you do have a parallelogram. All right, so we'll just go ahead and label what theorem it is that we are using. Okay, so we can just simply say opposite sides congruent. Then we'll draw an arrow to show our conclusion is that we have a parallelogram. All right, that's our justification to show that it is a parallelogram. All right, so now that you got that copied down, let's take a look at another type. We're going to be doing something similar. Okay, so here we have this quadrilateral. Again, looks like we got some algebra going on. We'll go through and find what each of these would equal and then see what we can apply to show we have a parallelogram here. All right, so first let's take a look at finding the length of QP. Okay, so we'll say QP is going to equal 7 times A. They're telling us what to use for A. So 7 times 2.4. All right, that's going to give us a length of 16.8. All right, let's take a look at what we have next for a side. We have RS, which is 2 times A plus 12. Okay, so we're going to use 2.4 again for A. So we have 2 times 2.4 plus 12. All right, and that'll also get me 16.8 for a length. All right, next we have some angles. We have angle Q and angle R, so let's calculate what those are so we can decide what is happening. All right, angle Q, we got 10 times B minus 16. All right, we're using 9 for B. So we got 10 times 9 minus 16. Work the math on that, and you end up with 64 degrees. And lastly, we have angle R. All right, angle R is 9 times B plus 25. So 9 times 9 plus 25. All right, that'll get me 106 degrees. All right, so that's what I have so far. And look at what's going on. QP and RS are congruent, so I can mark those as congruent. All right, and then looking at these angles, these are obviously not congruent, but they actually add up to 180 degrees. Okay, so these end up being supplementary. All right, this one's 74 degrees, 106 degrees. All right, so now let's take a look if one of the theorem applies to this. If we have two congruent sides and two angles consecutive next to each other that are supplementary, if we flip back and take a look at our theorems, This one doesn't apply. This one's pretty close, but we would need actually 3 numbers for angles to use this one. All right, so these other ones, if you look at each of these, none of these actually apply, okay, which sometimes happens. So let's figure out what we have to do next. Okay, so if you can't apply one right away, like we just did on the previous problem, we're going to have to use something else that we've already learned about in geometry to be able to use one of the current theorems. Okay, and something that's going to come up quite a bit with these. All right, if you take a look at what is going on here, we're going to extend the lines of this quadrilateral. So we'll extend that line, and we will extend this one, and then let's extend this line here. Okay, so if we do that, what we have going on is something that we did a few chapters ago, where you have 2 lines being intersected, being crossed by a third line called a transversal. All right, so you got 2 lines being crossed by a transversal. All right, and there's a multitude of theorems that we learned about that has to do with this situation. And if we specifically look at this angle and this angle, all right, these would actually be called same side interior angles, okay, because they're on the interior of this situation, and they're on the same side. And we've learned that same side interior angles, if they add up to 180 degrees, if they're supplementary, then that means we have parallel lines. All right, it's been a while, but that's a theorem we've worked with. Okay, so what I want to use, and just a spoiler here, this type of situation will come up quite often when we're working with parallelograms, is using same side interiors, alternate interior angles, all of that good stuff again. Okay, so here I'm going to be using same side interior angles theorem. All right, and here's what that theorem is from way back when. It says if you have a pair of same side interior angles, and if they are supplementary, then what that means is these 2 lines are going to be parallel. All right, we've written some proofs about that. Okay, so we had to use this theorem here, and we could show that those 2 lines are parallel because of this situation. All right, so sometimes we got to pull from something previously. Now if we go back and take a look at our theorems from today, we're going to be using this first one right here. All right, because here we have 2 parallel lines, and they are congruent, so we can apply this one here. All right, so we'll go ahead and write down, abbreviate what that one is. Okay, so we use this theorem, and then now we're using this one here that says if one pair of opposite sides are parallel and congruent, we'll use our arrow to show the conclusion. That means we have a parallelogram. All right, so sometimes you got to use something else before you can use one of the ones from today. Okay, so that's how we'd solve something like that. All right, try this one on your own. Okay, you're not going to have to find one from like way back when. You can just work this problem out, and you'll be able to use one of the theorems from today. So go ahead and do that, see what you come up with, and see what theorem would apply to that situation. All right, pause the video, and we'll take a look in just a couple of minutes. All right, let's check out what we would end up with for this one. Okay, so if we go through and we find out what each of these angles are, angle R comes out to 134, angle Q comes out to 46, angle S comes out to 46. Okay, so what we have happening is that angle R is supplementary to angle Q, and it's also supplementary to angle S. All right, and they are both consecutive. So we apply that theorem from today that says if you have a set of consecutive angles and they're supplementary, then you have a parallelogram. All right? Okay, so sometimes we have a situation where we don't have any numbers, but they give us some information, and we have to determine if this actually is a parallelogram or not. Sometimes it's a yes, sometimes it's a no. Sometimes we have enough information just to apply one of the theorems from today. Other times we need to use some other information for this. All right, this one is a case we got to use some other information. So we got to think of another theorem that we could use that would help us determine that this is a parallelogram. And what I'm going to use, I know I don't expect you guys to like know these things like all just to be able to use them right away. It'll take some thought to figure out what to use. But this one that we're going to use is our one that came from our triangle chapter, and it's going to be the third angle theorem. Okay, and what that theorem says is that if you have two angles of a triangle that are congruent to another triangle, then we know that the third angles of those triangles are going to be congruent. Okay, so because of this situation here, I know that this angle here will be congruent to this angle here. All right, and because of that situation, since like these are both congruent to each other and these are, then this entire angle is congruent to this entire angle down here. All right, so now we have enough from one of the theorems from today, because if opposite angles are congruent in your quadrilateral, then you do have a parallelogram. All right, so we won't flip back to those theorems. We'll just abbreviate what that theorem says. All right, it says if you have opposite angles congruent, then use our arrow for a conclusion. You would have a parallelogram like that. All right, so sometimes you got to find some other theorem to use before you can use one of the ones from today. All right, try this one out. See what you can come up with this. Decide if you do have enough information for a parallelogram or not. Sometimes it's a yes, sometimes a no. We'll pause the video and see what you guys get for this one. All right, let's take a look at what this would come out to be. We only have very little information. We just know that these opposite angles are congruent. Because of that little information, the answer is no. We don't have enough to be able to determine if this is a parallelogram or not. We would need something else to start putting some theorems together, but we don't have that. All right, there's just too little information, so we cannot prove that this is a parallelogram. All right, sometimes you'll run into that situation. All right, and the last thing we want to do is taking a look at a quadrilateral that has some coordinates. Okay, so one that would be placed on a coordinate grid. And we want to take those coordinates and be able to show that this quadrilateral is going to be a parallelogram. All right, and how we're going to show that is the definition of a parallelogram is it means it has opposite sides that are parallel. All right, so if we sketch ourselves a nice little parallelogram up here and we can label it JKLM. So JKLM. All right, there's our parallelogram. And the opposite sides are going to be parallel. So this side will be parallel to this one, and that side will be parallel to that side. All right, so to show that these opposite sides are going to be parallel, we want to calculate the slope of all the sides of the parallelogram, because if they are going to be parallel, the slopes will be the same. All right, they're going to have the same slope. Two lines that are parallel, We did some of that in chapter 3, I believe it was, where if we have two parallel lines, they're going to have the same exact slope. Okay, so that's what we're going to do. We're going to use that slope formula again. We have the slope formula right here. We're not going to spend a lot of time with the calculations because we've done this so much. So we're just going to take a look at what the slopes would be. All right, so first we'd calculate the slope of JK. So this line up here on top. So they calculated the slope of JK, and we ended up with -5 over top of 3. All right, just to show like how that slope formula would apply, just a refresher. So here we have x1, y1, and for k we have x2, y2. All right, in case you needed that, just to kind of get a jump start on this. So here's our y2 minus y1 and x2 minus x1 to get that slope. All right, then we're going to compare that slope to ML. Okay, and if we took and calculated the slope of ML, they end up having the same exact slope. They both have a slope of -5 over 3, so that would make these two lines parallel. Okay, so now let's take a look at our other two sides. We have JM and we have LK. So slope of JM comes out to 3/4 after that's been calculated. Slope of KL also comes out to 3/4. So these two sides are parallel. So yes, indeed, we do have a parallelogram, and we've shown that by calculating the slopes. Okay, so that's what you would do in a situation like that. I'll have you guys try one on your own, and then that'll be it for our notes today. All right, try this, see what you guys come up with. Maybe sketch yourself a little parallelogram if you want to get a visual. Calculate the slopes, see if indeed they do have parallel sides. Pause the video, take a couple minutes to work this out. All right, let's take a look at what this would come out to be. All right, so they calculated the slopes. Here we got KL and MN. All right, so KL, MN down here. Those indeed are parallel at -7 over 2. And our other two lines, we have LM and KN. Those slopes down here each have -1/4. So then those would be parallel as well. All right, so that's it. That would be our answers for that, and that's the end of lesson 6.3, you guys. I'll see you guys next time in class. I'll be back by then. We have, let's see, you guys will have a review assignment next from 6.1 to 6.3, and then a quiz following. All right, so get yourselves kind of ready for that. I'll see you soon. Thanks for watching this.